Welcome to our lecture video in Geotechnical Engineering. And this time, our topic is about stresses in soil. Now, let's have the three stresses that we will encounter in this topic. We have the first one, the intergranular stress, or that is the effective stress. It is the stress resulting from particle-to-particle contact of soil. The formula is given P sub E is equal to P sub T, that is the P total or the total stress, and minus the P sub W, or that is the pore water stress or the neutral stress. Okay? Now here's the second, the pore water pressure, or that is the neutral stress. It is the stress induced by water pressures, and the formula is P sub W is equal to gamma of water multiplied with the height or H sub W. Now, we need to take note that for soils above water table, PW is equal to 0. So, in this neutral stress or the pore water pressure, we are just concerned with the part of the soil that is submerged in water. And the third one, we have the total stress. It is the sum of the effective and the neutral stresses, or that is, it is the sum of the stresses induced by the particle-to-particle contact plus the stress induced by the water, or that is the water pressures. So P sub T is equal to P sub E plus P sub W, or that is P total is equal to P, or that is effective stress plus the neutral stress. Okay, let's consider the soil layer here. This is the stress in soil without seepage. Now, let's do some calculations for this soil layer. Let's compute for the total stress, neutral stress, and the effective stress for point A. Let's compute for the total stress, neutral stress, and effective stress for point B. And let's compute for the total stress, neutral stress, and effective stress of point C. Okay? So, it's already given, the calculation is already given in the study guide. But let's take a look on how those calculations were derived or were taken. Okay? So, from this, let's consider first the point A. Okay? So, let's focus on point A, calculating point A. The distance of point A from the ground surface is H4. Okay? And considering that this layer has a surcharge or an extra load above it, Q, that is in kilopascal. Okay? So let's solve first for, so we press at point A. So let's solve for total stress. So P total. Okay. What's the P total again? P total is the total stress that is being experienced at this point. So if we are talking about stress experienced at point A, we have two types of it, the surcharge and the stress induced by this layer here, the H sub 4 layer. Okay, so let's compute. So P total is equal to the surcharge. So obviously the unit should be in kilopascal. So Q is already in kilopascal. Plus, we have here the H4. We will have the given gamma moist. So we have here gamma moist times the height h 4. Remember that gamma is kilonewton per cubic meter, and H4 or H sub 4 is meter. Cancel that. So the resulting unit is kilonewton per meter squared, and that is in kilopascal. Okay? So next, we have the neutral stress or the pore water pressure, PW. What is mentioned a while ago is that the PW for soils above water table is equal to 0, because what we are considering here is the submerged part of the soil. So the PW here is 0. Effective stress, P sub E, is equal to P total minus PW. Okay? Or, so that is P effective is P total minus PW. Okay? Next, let's solve for point B. At point B. So, here is point B. The location of point B is H2 from the ground surface. And take note that point B is submerged in water, because the water table here is located H5 from point B. Okay? And the gamma here, since it is submerged, we have gamma sat 1 here. Okay? So for point B, we have P total is equal to the surcharge, the one above, plus gamma moist. Then gamma moist here is H1 from the soil surface up to the water table. So we will put here H1. Plus, next is H2. But since we are locating point B, we are going to use H5. So H1 and then H5. So gamma sat H5. That is for P total, or gamma sat 1. I should say gamma sat 1 because we have gamma sat 2. So gamma sat 1 H5. Next, P for water pressure, PW, and that is equal to gamma of W times H5, the portion which is submerged in water. Then P effective is equal to P total minus P water. That's the general formula. Or we can solve for P effective as Q, the surcharge, plus at gamma moist H1. And then when it comes to the submerged portion, the gamma sat, we will take the gamma effective 1. Or we can have that also as gamma prime 1. So it's the same, okay? Gamma buoyant 1, gamma buoyant 1, or gamma prime 1 is the same. And that is multiplied with H5. Okay? If you recall, gamma buoyant or gamma effective, so gamma buoyant equals gamma prime, gamma effective, that is equal to gamma sat minus the gamma of water. Okay? So just recap. Next, we have the point C. At point C. What's the P total? So, point C is located here. That is, point C is located H6 from the water table. And then it has gamma sat 2, and then gamma buoyant 1, gamma effective 2. Okay, so let's solve for P total. P total for point C is equal to Q plus gamma moist, the H4, H1. Okay, so we have there, what's happening here is Q, then at this portion, then at this portion, and later here. Okay, in order. Next, that is the gamma sat 1, and then we have H2 plus gamma sat 2, we have here H3. H3 is the location from the water table up to point C. Next, we have PW, pore water pressure. We have there gamma of water multiplied with H6. Okay, so that's the height of water from point C up to the water table there. Next, we have the P effective is equal to P total minus PW. Or, we can have it as Q plus gamma moist H1. Then when it comes to the submerged portion, we will take the gamma buoyant or gamma effective 1, H2 plus gamma buoyant or gamma effective 2, then we have there H3. Okay, so that's how the calculations were taken or derived. Okay? So let's solve for examples before we proceed to the other discussions. Okay, let's have here example number 1. A clay layer 4 meter thick rests beneath a deposit of submerged sand 8 meters thick. So there's no given figure. We need to draw the figure. So there's a clay layer that is 4 meters thick, and it is beneath a deposit of submerged sand 8 meters thick. The top of the sand is located 3 meters below the surface of a lake. So we have there clay, sand, and then lake. The saturated unit weight, so let's draw it first. So we have the lake. The lake is 3 meters deep because the top of the sand is located 3 meters below the surface of the lake. So we have here so this is the lake, 3 meters, and then we have 8 meters sand, and then we have 4 meters clay. So 3 meters 8 meters, and then 4 meters. So this is the lake, this is the sand, and this is the clay. Okay, so this is lake, and this is the sand, and this is the clay. Right? And it says there, the saturated unit weight of sand is 25 kilonewton per cubic meter. So gamma sat of sand is equal to 25 kilonewton per cubic meter. The saturated unit weight of sand is 25 kilonewton per cubic meter, and of clay we have it as 20 kilonewton per cubic meter. Determine the total vertical pressure P at mid-height of the clay layer. So this is the clay layer. The mid-height of the clay layer is located here. So this is 2 meters. So it's located, or it's asking for P total here at this point. Okay? Right, so let's solve for the P total. P total is equal to, of course, the weight of the water here first, and that is gamma of water times the height of the water. So how high is that height of water? So later on. Then plus the sand, the soil here. Okay, so we have it as gamma sat 1, and then we have it as H1 plus gamma sat 2 H2. That is equal to, gamma of water is 9.81 kilonewton per cubic meter multiplied with 3 meters of the lake, plus gamma sat is 25 kilonewton per cubic meter multiplied with 8 meters, plus gamma sat of clay is 20 kilonewton per cubic meter multiplied with 2 up to the mid-height of the clay layer. So P total is now equal to that is 269.43 kilopascal, or that is in kilonewton per meter square. Okay, so that's for number 1. So what we did is this layer first, the next is gamma sat here, and then gamma sat half here. So for P total. Next, number 2. A clay layer 25 thick or 25 feet thick is overlain with 50 feet thick of sand. Now we have 2 different soil layers here, and there is the word overlaying. So which one is above and which one is below? Okay. Now from the word overlaying, it means that something is above it. So this clay layer has something above it. It is overlain with something. So clay is below the sand layer. So if we draw the figure, so 50 feet for the sand. So let's make it longer. So 50 feet. Then here is the clay. Feet, 25 feet, and this is sand, and then this is clay. Then given the specific gravity of sand, given 2.71. The water table is 20 feet below the sand or the ground surface. So there is a water table located 20 feet below the sand or the ground surface. So here is the water table. We can have that symbol, or let's just say WT for water table. And that is located 20 feet below the ground surface. And then we have their saturated unit weight of clay is 141 PCF or pound per cubic foot. So 141 PCF for clay, gamma sand. 141 PCF. The sand below the water table has a unit weight of 128 PCF. The water table is here, and then the sand below the water table has a unit weight of 128. Therefore, we can conclude that it's talking about gamma sand, PCF. The sand above the water table has average moisture content. Of course, remember capillarity. So that means there is moist above this water table, and it is in 20%. After drying, the sand was found to have a dry unit weight of 92 PCF. So upon drying, it says there, sand has gamma D equal to 92 PCF. Now, why did I put it outside? So why did I remove it from the figure? This is to remind me that this situation, this gamma D, is a laboratory setup. Meaning, to obtain your gamma D, gamma dry, the soil is removed and it is oven dried. So we have there gamma D 92 PCF. Determine the effective stress at the mid-height of the clay layer. So it's looking for the effective stress here, PE, P effective. And that is at the mid-height of the clay layer. So that is 12.5 feet. Okay, so let's solve this. P effective. So we can solve this by two methods, but first we need to find the value for gamma moist. Why we need to find the value of gamma moist? Remember, this is just gamma D, wherein we took the soil and oven dried it. But what we need here is to compute for P effective in C2. So what is gamma moist? So to solve for gamma moist, the gamma moist here, formula for gamma m is equal to G plus GMC all over 1 plus E gamma of water. But the problem here is we don't have the value for E. So we need to solve for E first. So let's set this aside. Okay, so let's solve for gamma, or for E, for the void ratio first. So given gamma D is equal to G over 1 plus E gamma of water. So we have there 92 pound per cubic foot is equal to, so pound per cubic foot is equal to G of 2.71 all over 1 plus E, and then gamma of water in English system, that is 62.4 pound per cubic foot. Cancel this unit. What's left is the value for E. That is equal to 0.838. Now we can now solve for gamma moist. Now to solve for gamma moist, that is equal to 2.71 plus 2.71. MC, moisture content, is 20%. That is 0.2 over 1 plus 0.838, then 9, that is 62.4. So gamma moist is now equal to gamma moist is now equal to 110.4 pound per cubic foot. Okay, so now we have the gamma moist. Next, let's solve for the P effective. So to find P effective, if you recall, P effective is equal to P total minus P water. So let's solve for the P total first. P total is equal to the gamma moist, the gamma sat here, and then half of clay using gamma sat. Okay, so gamma moist 110.4, and then it is 20 feet, plus the gamma sat of the sand is 128, and that is 30 feet. It's 30 feet here. So then we have there, plus the mid height of the clay layer, we have there 141 PCF gamma sat, that is 12.5. So P total now is equal to 7810.5 PCF. Next, let's find P water. So P water is equal to the height submerged, the total height of the soil submerged up to the point where we are taking the effective stress. So it's from here up to here. So that is your HW for DPW. Right? So that is 30 plus 12.5. Then PW is gamma W 62.4 times 30 plus 12.5. So PW is 2652 It's not PCF. It should be pound per square foot. So, pound per square foot, or that is in PSF. Okay? Therefore, P effective is now equal to P total minus P water. That is equal to 5158.8 PSF, or pound per square foot. Okay, so that's for P effective. Now, there is another solution for this, for the P effective, or we can just simply use the gamma effective. So, how do we do that? How do we use the gamma effective? First, let's compute the one outside the water table or above the water table. Above the water table, you have gamma M. So, gamma M is 110.4. 110.4 multiplied with the height of gamma M. Next is the one who is submerged, gamma sat, 128 PCF. 128. You deduct the gamma of water, which is 62.4. This is to get the gamma effective. So 62.4, let's put that here, gamma effective. Multiply with the height there is 30. Plus, another gamma sat is found at the clay layer, 141 minus 62.4, and then it is mid-height of 12.5. P effective now is equal to, so that is 5158.5 pound per square foot. Okay, so you can use this formula, or you can just use this formula. Okay? Either ways, it arrives at the same answer. So that's for number 2. Okay, so let's go to number 3. The soil shown below has a void ratio of 0.50. So there's only one type of soil here in this figure. We have sand. So the void ratio given, E, is equal to 0.50. Okay? And G, or the specific gravity G, is equal to 2.70. H1 is 1.5, so 1.5 meters. Then H2 is 3 meters. What is the effective unit weight of sand in kilonewton per cubic meter? So it's looking for the effective unit weight of sand. So we have 2 ways to solve for the gamma effective. So it's looking for gamma effective, or that is gamma buoyant. Okay. So there is 2 ways. Number 1. The first one is the formula itself. The formula for gamma buoyant is equal to G minus 1 all over 1 plus E gamma W. So that is 2.7 minus 1 all over 1 plus 0.5. Gamma W, gamma of water, is 9.81. and gamma effective is now equal to 11.118 kilonewton per cubic meter. Now how about if you forgot the formula for gamma effective? So we can solve it via gamma sat. So remember that gamma effective is equal to gamma sat minus gamma of water. So for gamma sat, we have there G plus E over 1 plus E. So you just have these options in case it happens that you forget the formula for gamma effective. So that is equal to 2.7 plus 0.5 all over 1 plus 0.5 gamma of water 9.81. So gamma sat is now equal to 20.928. So kilonewton per cubic meter. Therefore, gamma prime or gamma effective now is equal to 20.928 minus 9.81. That is equal to 11.118 kilonewton per cubic meter. So that's for letter A. Letter B, what is the effective stress at point A? So this is point A. And point A is located 1.5, that is 1.5 meter plus 3 meter here from the water surface. Okay, so we're looking for effective stress PE. So effective unit weight is different from the effective stress. So it is important that you acquaint yourself with these names so that you will not interchange them later on. So effective unit weight is in kilonewton per cubic meter. Effective stress is in kilopascal. Letter C, we're looking for the critical hydraulic gradient of sand for the quicksand condition, that is I sub C. Now, I sub C, actually, the formula of I sub C is this portion here of the formula for gamma effective. Okay, so let's solve for letter B, effective stress at point A. So what is the effective stress at point A? Again, we can solve this by the total, P total minus PW. But we can have the shortcut. So the shorter way is P effective is equal to, should we include the water for the P effective? The answer is no. You just have to remove it already. Remove the water. Just go to the soil. The soil here has gamma sat of 20.928 minus the gamma of water. We have there 9.81. Remember the definition for effective stress is the particle-to-particle contact. So the water pressure has nothing to do with the effective stress. So we have to deduct or remove the water here. So there is no point in including the water of 1.5 meter here. So that is equal to 33.354 kilopascal. So that's the effective stress. Now, for those who still wanted to go to the general formula for effective stress, that is the P total minus P water. This is also as a form of checking in case you're not quite sure if you did the shortcut here. So P total. P total is water and sand. H1, H2. So the gamma of water is 9.81 times 1.5 plus the sand. The sand is gamma sat, that is 20.928 times 3. Okay, so 3. So P total is equal to 77.499 kilopascal. P water. P water is the height of the water from the water surface up to the point. So that is 1.5 plus 3. So that is 9.81 times 1.5 plus 3. So that is 44.145 kilopascal. Therefore, P effective now is equal to 77.499 minus 44.145, and then that is equal to 33.354 kilopascal. See, it's still the same. Now, the reason why you need to acquaint with these two solutions is that it serves as a way to check if your answer is correct. Next, letter C. We're looking for the critical hydraulic gradient of sand, I sub C, using this formula. Okay. So for the I sub C, that is equal to G minus 1 over 1 plus E, 2.7 minus 1 over 1 plus 0.5. I sub C is equal to 1.133. Okay, so that's for number 3. Next, let's go to number 4. A soil deposit is shown below. The groundwater table initially at the ground surface was lowered to a depth of 25 feet below the ground. Okay, so initially we have here the water table. So this is the initial condition. This is the water table. Okay. So then it was lowered to a depth of 25 feet below the ground. After such lowering, the degree of saturation of the sand above water table was lowered to 20%. Letter A, what is the vertical effective pressure at the mid-height of the clay layer? It's asking for effective pressure. So it's looking for the mid-height of the clay layer. So P sub E. Before lowering. Okay. Then letter B, what is the vertical effective stress or effective pressure at the mid-height of the clay layer after lowering? The lowering of 25 feet in PSL. C, what is the vertical effective pressure when there is no water in the sand layer? Okay, so it means it's in here. So we have 3 conditions. So the first one is water table at the ground surface. The second is here at 25 feet below the ground. And the third one is located here in the boundary of the sand and the clay. Okay, so let's have the first one. Find the effective stress or effective pressure when the water table is at the ground surface. And remember, it's looking for the effective stress at mid-height of the clay layer. So let's point here. Let's put here. That's the location. So mid-height. So this is 12.5 feet. Okay. So letter A. Before lowering, what is the effective stress? So gamma sat is given already. Okay, so there's gamma sat already here. Good. And then there's also gamma sat for water. So we're good to go. P effective is the gamma sat. 135 minus, this is in English, so we have there 62.4 multiplied with the height, that is 50 feet. So plus, we have the clay layer, and that is equal to 120 minus 62.4 times 12.5. So P effective now is equal to 4,350 PSF, or pound per square foot. So that is for letter A. Before it was lowered. And how do we draw the next one? Okay, so maybe I could use some drawings here. Picture. So it will become clearer. For the second condition, remember that the second condition is it was lowered 25 feet, and then in such lowering, the degree of saturation of the sand above the water table was lowered to, so is there lowered to 20%. So we have a 20% saturation. Okay. So if it says there lowered to 20%, is that 100% minus 20? So the question here is, if it says there degree of saturation was lowered to 20%. So originally, since the water, the sand is submerged with water, S is equal to 1, or that is 100%. If it says there degree of saturation was lowered to 20%, does that mean that the second condition here, the second condition here means 100% minus 20%, or is that S2 is equal to 20%? So it says there lowered to 20%. So this is the correct condition for S2, or the degree of saturation 2. So we have S2 is equal to 20%. So we can also use the wordings reduced to How about if it says there, degree of saturation was lowered by 20%? If it says there lowered by 20%, then it means 20% was reduced from the original 100%. Okay? So, in solving these geotechnical problems, there's also the need for comprehension. Okay? Reading comprehension. Okay, so let's go to the second condition. Lowered here at 25 feet. Okay. So this is 25 feet. And then still we are looking for the effective stress at the mid-height of the clay layer, 12.5 feet. And we have here, since it is lowered to 20%, that means okay, S is equal to 0.2. So that is 20%. Okay. So it means this is no longer a gamma sat. It means this is not a gamma sat anymore. So gamma sat 135 is no longer located here. Gamma sat is located at this 135 PCF. So what we have here is gamma moist. We need gamma moist. How about the gamma D here? What can we use for gamma D? You can use gamma D in order to find the value of gamma M. Okay? So let's solve for the value for gamma M. To solve for this one, we need to find, so gamma D is equal to G 1 plus E gamma of water, given gamma D 116. Now specific gravity is not given, so it's unknown, as well as the void ratio. And then we have gamma of water 62.4 because we're using English. So since there is two unknowns, we need two equations. And we can use the other one, the gamma sat, for the second equation. Okay, so 1.859 plus 1.859 E is equal to G. So the first equation here is G minus 1.859 E is equal to 1.859. So this is equation number 1. The second equation is gamma sat. So gamma sat is equal to G plus E over 1 plus E gamma of water. So gamma sat is given for sand as 135 G plus E over 1 plus E, gamma of water 62.4. Then we have here 2.163 plus 2.163 E is equal to G plus E. And we have here G minus 1.163 E equals 2.16. Equation number 2. Okay, so using your calculator, you can now solve for the values of G and E. Okay, so let's add. So G now here is equal to 2.67 and E is 0.437. Therefore, gamma moist is equal to G plus SE over 1 plus E gamma of water, that is equal to 2.67 plus 0.2 times 0.437 all over 1 plus 0.437 times gamma of water 62.4. So gamma moist is now equal to 119.74 PCF or pound per cubic foot. Okay, now we were able to find the value for gamma moist. We can now solve for P effective. So P effective of 25 feet there above the water table is 119.74 times 25 feet. Okay, plus the one that is submerged, the gamma sat of the sand 135 minus 62.4 of water multiplied with another 25 feet plus the gamma sat of clay, which is 120 minus 62.4 of water multiplied with the mid-height of the clay layer 12.5. So P effective is now equal to 5,530 PSF, or that is pound per square foot. So that's for the second condition. So 5,530, this one is 4,350. So when the water table was lowered, the effective stress is stronger. Let's go to the third condition. The third condition here is find the vertical effective stress when there is no water in the sand layer. So meaning the water table is located here in the boundary of sand and clay, the division of sand and clay. So again, let's have picture. Let's put here the third condition. So here is the water table. So as we have solved a while ago, this is no longer gamma sat. So gamma sat for sand is gone, but it is replaced with gamma moist. Gamma moist of 119.74 what we're looking for here is the effective stress at the mid-height of the clay layer, located here. That is 12.5 feet. So for letter C, P effective is now equal to the gamma moist of 119.74 times 50 plus the saturated of clay, saturated unit weight 120 minus the water multiplied with the mid height of the clay layer 12.5. So P effective now is equal to 6,710 pound per square foot. Okay, so that's the answers for number 4. Okay, so screenshot first. Next is number 5. Okay, that's the last for this video. So for number 5, we have the groundwater level in a thick, very fine sand deposit. Okay, so the groundwater table in a thick, very fine sand deposit is located 2 meters below the ground surface. Above the free groundwater line, the sand is saturated by capillary action. The unit weight of the saturated sand is 20.3 kilonewton per cubic meter. What is the total stress in kilopascal in a horizontal plane A located 4.5 meter below the ground surface? So we only have one type of soil, and that is sand. So if we draw this, so it says there is a groundwater level that is 2 meters below the ground surface. So that means, okay, so this is purely sand, and the water table or the groundwater level is 2 meters. Okay, so the groundwater level is 2 meters from the ground surface. Okay, so this is purely sand. Above the free groundwater line, the sand is saturated by capillary action. So it is saturated by capillary action, and that is, if this is a water table, so what do you call the gamma here? Is it gamma sat or gamma moist? Because the word here that is used is saturated. The sand is saturated, and it is given as 20.3. So this is gamma moist. It is saturated only by capillary action. It is not submerged. That's why we will use here gamma moist is equal to 20.3 kilonewton per cubic meter. So gamma moist is 20.3. And it says here, the unit weight of the saturated sand is 20.3. Okay. So saturation here, gamma sat, is also equal to 20.3 kilonewton per cubic meter. Okay. Then, so there is no other given, just that. The saturation of sand is 20.3. Okay, so we will use gamma M 20.3 kilonewton per cubic meter and gamma sat 20.3 kilonewton per cubic meter. Okay. Okay, so let's go to letter A. What is the total stress in kilopascal on a horizontal plane A located 4.5 meters below the ground surface? So it's looking for this one here from this, so 4.5 meters, and so what is the P effective here at this point? Point A, so it's given point A. Point A. Okay? So if that is 4.5 meters, so this is 2.5 meters. Alright? Find the total stress. Letter A. P total is equal to 20.3 times 2 plus 20.3 times 2.5. So P total is equal to 91.35 kilopascal. B, what is the pore water pressure in kilopascal at this plane? PW is equal to, of course we are using 9.81 for the water. The height is from the water table or water level, so that is 2.5 meters. So PW is now equal to 24.525 kilopascal. Now letter C, what is the effective vertical stress in kilopascal in plane A? So obviously we have there P effective, P total minus P W, and that is 91.35 minus 24.525. So P effective is now equal to 66.825 kilopascal. Now we can have other solution, of course, or so for we have here P effective is equal to 20.3 times 2 for the gamma moist. For the gamma sat, you deduct the water. 9.81 times 2.5. So P effective now is equal to 66.825 kilopascal. Still the same. Right? So that's for number 5. We cannot solve for gamma M here because there is no E, there is no G. Okay. But says there it is saturated by capillary action and the saturation of sand is 20.3. Right? So that's for number 5. Okay, so that's all for this video, and stay tuned for the parts 2 and 3 for the topic soil stresses or stresses in soil.